This is the nomenclature video by Giselle, Cruz, period 2. Now, firstly, we're going to start with what a caution is. Okay, a caution is a positive ion, meaning it has more protons than electrons. Okay? This is formed when atoms lose electrons. An example of this would be Ca+, which is calcium, and Be2+, which is beryllium. Now, there are two different types of cautions. These are the ones with a definite charge. As you can see, that meaning they only have one charge. However, in the periodic table, there are some elements that have more than one charge, and that would be these in the middle. Okay? And these one with double charges would require a Roman numeral when they're being written down. For example, Fe has two charges, 3+ and 2 positives, Okay. In FeCl2, when you write it out, it would have to be written with the Roman numeral, okay? It would be, since there's a 2 at the end right here, it'd be iron 2. This is chloride. To identify the difference between them, just know that the one without the Roman numeral will only have one charge, and when they have two charges, they'll need a Roman numeral, which will be found at the end of the second element or at the end of the element if it's just by itself. Okay. Moving on. A caution is an ion, and there's another type of ion which we would call an anion, which just means that it has that contrary to a caution, it has more electrons than protons, meaning it have a negative charge. Yes. Okay. These are formed when the atoms gain electrons. And these are special because when you write them out, when they're together with a separate element, you have to add the "ide" ending, okay? For example, one of these would be oxygen, which you can tell is an anion because on the periodic table it has a negative charge, which would be the nonmetals. You see, negative charge, and negative charge, negative charge. Okay, so oxygen, when written in this form right here, and it's on the second end, it would be written oxide. You can see right here how it happened. This is Cl, this is chlorine originally, and then we made it into chloride. You see that "ide" ending. Remember that. To identify these, you'll just have to look for the nonmetals with negative charges. Okay, now we're moving on to ionic compounds and how to combine a caution with an anion. Okay, for this, we'll need our periodic table. But let's start with what an ionic compound is. An ionic compound, we'll call it IC for short, are the combination of two types of ions. For this example, we'll use anions and cautions, which we just learned about previously. In order to do this, we'll need the charge of each ion, which is why we'll need the periodic table. let's say we have Ba2, which is beryllium, and F, which is fluorine. Sorry. You would cross the charges. Forget about the sign. The sign isn't important anymore. And right here, I know it seems like just a negative sign, but there's really a 1 there, okay? So you'd cross the charges, but since it's not really there, you just do Ba, nothing, and F, and you cross charge it here. So it'd be A2, because we dragged it over from right here. Is that from right there? Good. However, sometimes when you have some that have the opposite charge, then you won't need to do this because they cancel each other out. What I'm talking about is when you have, for example, sodium and fluorine. Now, they have the opposite charges. So when you cross them over, these would just cancel each other out. So you'd be left with sodium fluoride. Now we're going to do covalent compounds, or CC for short. These are molecular compounds. And what this is the combination of two types of nonmetals. In order to identify this, this is what you're going to have to look for when you're doing molecular compounds. Nonmetals can be found on the periodic table. They're right here. And when these two are together, you're going to need to use a special chart that is filled with Greek prefixes. Now, what I'm talking about is you'll have to use, one would be for mono. Okay, and these tell how many of that particular atom there are, okay? If there's 2, it'd be di. Prefixes, and prefixes mean they go before, at the front of this element, sorry. Okay, now 3 would be tri. 4, tetra. 5 is penta. 6 is hexa. 7 is hepta. 8 is octa. 9 is nona. And 10 is deca. Now, as I said, these are to tell how many atoms are in that element, so you forget about the charges. Yay! Oh, but just a warning. Mono is not used in the first element if it only has 1. Okay. Given N2O3, when we look at the periodic table, we know that these are nonmetals. So, let's see. There's 2 of nitrogen and there's 3 of oxygen. When written out, remember, there still is an "ide" ending, but only for the second one. You leave the first one alone. So that means this would be di. Remember, if there's 2, that means di. Dinitrogen. Trioxide, because you still add the "ide" ending to the second one since it's still a non-metal. And 3 is tri. Dinitrogen trioxide. And another one, let's do
CO, which should just be carbon oxide. Because, as you can see, there's only one. Well, actually, it would be carbon monoxide, since there's only one. And what did we say? Mono isn't used on the first element, so it's carbon. And there's one here, so monoxide. Now we're going to move on to polyatomic. How to identify them, what special rules do they have, and when we have to use the parentheses. Now, polyatomics consist of more than one ion. When you come across a polyatomic ion, you'll be able to identify it because it won't be on the periodic table, since they're a combination, or it'll have a parentheses around it. Now, what I'm talking about when I say the parentheses is when you come across like NH4+, and then it'll have a parentheses around it. This being ammonium ion. Now, another one would be OH, which is hydroxide. CN, which would be cyanide. These parentheses right here are only added when you'll need to add another number besides the given one. Like right here, let's say we had copper, and then we have NH4+, which is our polyatomic. We need to add parentheses because we still need to add the charge of the copper, okay? This being, in this case, let's just say 2. You see the parentheses right here? It's used to differentiate the number that belongs to it versus the charge of the copper. Now, throughout this video, I've been doing this thing that I haven't explained yet, which is going from, oh, that's a horrible color, sorry, which is going from formula to name, and vice versa. First, we'll start with formula to name, yes? Okay. Now, to do this, we need to, 1, figure out the charge of the caution. 2, write out the name. Now, formula to name. First, we have to figure out the charge. Second, write out the caution. Third, which is optional because it's not always going to have Roman numerals. Write out Roman numerals in parentheses to show caution's charge. And 4, write the name of the ion. Now, we're going to have an example here. Let's say we had Fe0. O. You're probably confused. Like, what? There's no numbers. How am I supposed to figure out the charge? But remember, if they have the opposite charge, then that means they cancel each other out and you don't have to write it down. So meaning these two have the opposite charge. And if we look on here, that way oxygen has a 2, meaning that iron in this instance would be a 2 also. Of course, opposite charges. So that means let's write a virtual 2 to help us there. at least for the Fe, because for the O it doesn't matter. Fe stands for iron, and it has a charge of 2, which we put in parentheses. And the anion, we add an "ide" ending, so it'd be iron 2 oxide. We figured out the charge. We wrote out the caution, and in this case, we did have to write a Roman numeral in parentheses to show the caution's charge. And we wrote out the name of the anion while remembering the "ide" ending. Another example, let's do Cu Br2. This one's much more simpler. If we look at the periodic table, we'll know that Cu is copper. Its charge here is 2. And Br is bromine, and this O, we add the "ide" ending to our anion, and bromine becomes bromide. Again, we figured out the charge, we wrote out the caution. In this case, again, we did write out the Roman numeral in parentheses to show its charge, and we wrote the name of the anion with the "ide" ending. Now, what happens if we want to go from name to formula? Well, First, we write out symbols for the 2 types of ions. Second, we balance the charge to write formulas. Knowing this, we're going to give you a little example here. Let's say we have cobalt, chloride. Well, if we wrote this, we first have to write out the symbols for the 2 types of ions. Cobalt is CO, with right here a charge of 3. And chloride is chlorine if we take off the "ide" ending, and it has negative charge. Okay. Second, balance out the charge to write the formula. This basically means crossing them over, which would leave CO plain, since that's just that, like just that. Whenever it's just the negative or the positive, you don't have to write it. And Cl3. Another example would be tin, 4 oxide. Individually, we know that tin is SN4, as we can see from here. An oxide is oxygen, which is O2. Or plus, sorry, that's supposed to be up there. Okay. So, as we did prior, we take those charges, cross them over, And we'd be left with SN2O4. And we have covered all our topics for this video. So thank you for watching.